In question 37, they tell us the revenue function and they tell us the cost function. And then they say if you are trying to operate where marginal cost, so marginal revenue, equals marginal cost. So you have to recognize that marginal revenue equals R prime, and marginal cost equals C prime. So you want to set those equal, and then you want to figure out the X. Okay, so let's get to work. So R prime is just going to be 100 minus 0.02, right? Whoops, 0.02. Yep, okay, that's R prime. What is, oh sorry, I did my X. Okay, and then C prime is just 50. So if you want to operate where marginal revenue equals marginal cost, just set those two equations equal to each other and solve for the X. So this is going to be 50 equals 0.02x. So divide 50 by 0.02 and you get X equals 2500. And I'm not given units, so I'm not giving units back, and you are done. So let's move on to question 38. Okay, in question 38, they say find the minimum cost of that function and verify you have found the minimum by first and second derivative tests. So lots of times when I do this, I like to divide my paper into a grid. Okay, so in my grid, I'm going to have the following. Up here in the upper left-hand corner, I guess the second quadrant, I'm going to find what my critical values are. I do that by taking my first derivative, and I get 3x squared minus 10x minus 13. All right, so I'm going to have to do some factoring with this because I get the critical values by setting that equal to 0. So I'm going to decompose my middle term. So if you can't do this kind of factoring, come and see me, because this is going to be very important to you being able to solve these problems, so you have to know how to factor. Okay, so given the first pair, what do they have in common? Just an x. So I have 3x minus 13, bring down the plus, put the 1 there so that you can write this again. And my factors now, so C prime equals x plus 1 and 3x minus 13. Okay, I'm going to take a second now just to give myself my second derivative also, which would be 6x minus 10. So I see I have one inflection point and two critical numbers. So now in this lower quadrant, so this would be quadrant, 1, 2, 3, I'm going to establish my sign chart. And so my two critical values, if I take my first factor of x plus 1 and set it equal to 0, I get a negative 1. If I set 3x minus 13 equal to 0, I get 13 thirds. So what I want to do, I want to evaluate that function for its slope. I want to figure out what direction my function's heading, and then I want to affirm it by taking the second derivative. Okay, so at negative 1, if I pick a number to the left, so let's pick negative 2, and plug it in my factors, that'll get me a negative, that'll get me a negative, right? Let's just think about this. And a negative times a negative is a positive, so my slope is a positive. The direction my function is heading is in an upward fashion. Now pick a number between negative 1 and 13 thirds, and the easiest is 0. So that's going to give me a positive times a negative, so that's going to be a negative. My slope gives me a function that's heading down. And lastly, so 13/3 is a little bigger than 4, right? It's 4 1/3, so let's pick 5. If I put a 5 in my first factor, I get a positive. Put a 5 in my second factor, I get a positive. Positive times positive is a positive, and my function is heading back up. Okay, so let's now analyze the second derivative. When you do a second derivative test, you test right on the critical value. So if my critical value is -1 and I plug in a -1 in my second derivative, I'm going to get -6 minus 10, which is a negative, and therefore my function is concave down, which affirms my thought that my -1 critical value gave me a max. Okay, then check your 13/3, which is about 4 and a little bit. So that's going to give me a positive for my second derivative when I plug in 13/3 for the x. And if it's positive, then that means my concavity is concave up, which affirms the fact that I have a minimum. Okay, so then up in this upper quadrant, the first quadrant, I'm going to now evaluate if my x is -1, plug that in your original equation and you should get 157. If your x is 13/3, plug that in the original equation and I got 81.1. So I did use my calculator for that. Okay, so then what do I know? I should have a statement. So here should be your critical value statement. So again, talk about the derivative, talk about the result of your second derivative test, and by the first and second derivative test, the first is checking the sign change of the slope, the second is checking the concavity, and you have a max at -1, so that max point is going to be -1, 157, and you're going to have a min at the point 13/3, 81.8. Okay, so now you're ready to give yourself a little graph in this lower quadrant. So it looks like, for the most part, everything is above the x-axis. So if this is -1, and this can be 1, 2, 3, 4, 5, so that's like 4 1/3. It looks like I have to go through 150, so why not go by 20s? So 20, 40, 60, 80, 100, 20, 40, 60, 80, 200. Okay, so that's going to be by 20s. So my x-intercept is at 140, so 150. 20, 40, 60, 80, 100, 20, 40. So that's going to happen right there. At -1, I have a value of 157. So if that's 150, it's a little bit higher. And at 13/3, which say is about there, I have a value of 81. So that's 20, 40, 60, 80, a little bit over there. So what's happening? So if I have a max here, then my function is going to go here through the y-intercept and heading down to a minimum right there and back up. So there's my graph. So that's the 4-quadrant approach. And you should go back, make sure you understand all the pieces, and that you could recreate this. So for this last problem, I was having a little difficulty getting this to copy correctly, so I just took a picture of it. So let's go through this. It says the average weekly temperature, so it's Fahrenheit degrees, in Washington, D.C., T weeks after the beginning of the year is this big equation. Okay? But I don't want to use that equation because they gave me a graph. So they want me to understand that's the equation. And what is that the equation of? The average weekly temperature. but now they want me to answer questions only looking at the graph, so don't be taking the derivative. Okay, so I have already written my answer here, but let me tell you why that is the answer. What is the average weekly temperature at week 18? What do I do to do that? So let's make this bigger for a second. Week 18 happens about right here, so go straight up, and read over. So I went straight up to my function, and I read over, and that's how I got 70 degrees, okay? So then it says to me, at week 20, how fast is the temperature changing? So what you will need to do is you will need to go to week 20, which is where this little dot is right here. And you will need to draw a straight line. So let's see if I can do that. So if that's my straight line, and again, I'm not using a ruler right now, but even looking at that, I see I have two good points. One good point there, one good point there. If they want me to figure out what the rate of change is, I'm going to use those points. So I guess this is a better point right here, right? So what are those points? So I see that my y is 50. So over here I'm going to put a 50 for my y. And I see that my other y is 65. And now I'm going to zoom out a little bit and see if I can figure out what my x's are. So my x that goes with the 50 is 5. So let me just slide this down a little bit. And my x that goes with the 65, so looking down, is 15. So let's get the rate of change. So change in y over change in x. So 65, is that right? Hold on one second. Yes. 65 minus 50 is going to be 15. And 15 minus 5 is going to be 10. So 15 divided by 10 is 1.5 is my rate of change. So right here on this line, I would put 1.5, make that a little bit bigger, 1.5, and this is going to be degrees per week. Okay? All right, let's go to the next one. Okay, problem number C. When I look at C, it says during which weeks, so they're always giving you a head up, that's going to be more than 1 week. During which weeks is the average weekly temperature equal to 39 degrees? So you're going to look on your y-axis and figure out where 39 degrees is. So let me just change my color. And what you would do is you would draw a line across. So what I did, I put these little half marks. That's where 39 degrees is. So now look down and see what x's cross your function. So that's one that looks about 7. Here's another one down there. What was that one? Let me just make this. That's 44. That makes sense. And then this last one I said was about 58. So that gives you the answer for C. Okay, D, this weird thing happened and the falling word got pulled out. So when is the average weekly temperature falling at the rate of 1 degree per week? That means that you have to have a slope equal to -1. Okay, if it's falling, it's -1. So what you want to do, I kind of put this in here to give you a guide. That slope is +1. So I would draw a line that would be -1 and see where that lines up. So if you're going to have, if every box goes up by 5s, then a -1 would kind of have a slope that's parallel to this. Let me just draw another line in here. Okay, we'll use that color. So if I connect these points, that's going to be a slope of -1. Okay, whoops, let me go back. Okay, so I'm just taking these points and I'm going to find a slope that looks like that. So I would say that right about here I'm finding a slope of -1. So that's definitely one time, and I'm just going to do one time. So I would say, doing this kind of rough estimation, because I'm not doing with a ruler because of this iPad, so I'm saying that right at about, I don't know, 28 weeks, it looks like my temperature is changing at a rate of -1 degree per week. Okay, so let me erase some of this because this is getting rather cumbersome. And let's go to the next question. So the next question says, when is the average weekly temperature greatest? Alright, so that's easy. When is it at its max? Right here. When does that happen? Boom. 25. Done. When is it at its min? Well, 1 over here is negative. That makes no sense. So let's go with this one right here. And I said that's about 52. That seems reasonable. Alright, now the next question takes a little interpretation. It says, when is the average weekly temperature increasing the fastest? So again, let me just erase some of the things I have here. And where is it increasing at the greatest rate? That's asking me for an inflection point. So give me an inflection point. I said it looked to me, and I'll change colors again, that right here is a positive inflection point. And that ends up being at 13 weeks. So that's when it's increasing the fastest. Right here is a negative inflection point. So that's where it's decreasing the fastest, and that looked about 37 weeks. And that completes our midterm review packet. Thank you very much.